Hello, cherubs. I miss you guys. Hope you are having a great day. Today we're going to keep the lesson brief. I'm shooting for a 15-minute video, and then you guys will have some time to do some practice tests. First, a little overview of what I'm looking at. If you were going to do the extra credit assignment, I'm making the extra credit assignment a turn-in. So I'm asking you to take 3 pictures of your project that you've completed. One that gives me a nice clear image of the arts and crafts part, one that gives a nice clear image of what you wrote up, and then one where you are actually in the picture with your project. That way I know in fact it is your project. You do those 3 things, it all looks good, you get 5 points on your lowest test score. Second point is the test that we're not having today. I've rescheduled for Tuesday with hopes that we will be in Monday. We will review, knock out a test, and then we'll finish out the little part of the second trimester. We'll see what happens. If we don't actually meet face-to-face, we will conference through Schoology. So hopefully you guys are somewhat familiar. All your teachers are talking about it. If you need help with that, you can either email me, you can contact the help desk, but that is going to be the method if we are not in school on Monday. All right, so let's get into the notes because that's the point of this video. When we spoke last, we were talking about tides, right? High tide, low tide, diurnal system, or twice daily. I'm going to review very quickly through these different slides just to refresh your memory because I know it's been a couple days. You can always slow down the video or you can watch it a second time if you need to pick up a couple things. So the shoreline is that area right along the coast. In this chapter we actually get into the different types of shorelines. So we talk about beach, and in the sandy sense we talk about rocky beaches. We'll end up talking about wetlands and organic coastlines as we move forward. But high tide, low tide affects a particular area, and that land that is saturated during high tide and exposed during low tide is called our intertidal zone. That was that nice little picture, and many of us are familiar with this if we go down to the beach. It's usually where you're going to find, as you're seeing here, a little bit of seaweed and random sediment. Then we mentioned the tidal bore, and this is the phenomenon that happens when the high tide comes in, and you see that this push or cloud that kind of pushes up the river channel or into an estuary. Hopefully you remember estuary, that's that mixing zone with the brackish water. Now, with tides, we know that the moon, major gravitational pull, and the sun, about half as much gravitational pull on the Earth's water and the Earth itself, which is why wherever the moon is, that's where we're going to have the greatest amount of pull. That's what we're going to call the sublunar bulge. And then on the other side of the Earth is where we're going to have that secondary bulge. On the sides, right, we'll have a depression, and that's in essence where you get your 2 high tides, both bulge, depressions, your low tides. Let's also remember that the rotation of the Earth in conjunction with the revolution of the moon creates this centrifugal force, this idea that the water is actually trying to escape or push away. Centripetal was in, centrifugal is pushing away. So when we take centrifugal force and gravitational attraction, we put them together. This is where our tide generating force comes from. As I just mentioned, your sublunar bulge and secondary bulge, these are responsible for our high tides. And that's a great little diagram right there, showing you on one side that the water is being pulled. This is going to be the greater bulge, so that is your sublunar. sublunar or superlunar, however you want to think about it. And then over here, you still have a high tide. It's not as pronounced, but it's still there. And then the depression. So if you're not in the bulge and you're perpendicular to that line, then you're going to have a depression. You're going to have a lower level. So going back to the diagram that you just looked at, right? If we have a bulge here and a bulge here, well then over here this is going to be low tide. Over here this is going to be low tide. High tide, high tide. Wow, we just made a diurnal system. Yay. And then the tidal system itself has a lot of different factors. And we talked a little bit about this, but I want to just get the key points back down here. Right? The tilt of the Earth. Tilt of the Earth, we know, is 23.5 degrees. Because the Earth is tilted, we don't just have an even pull right on the equator. Instead, as the Earth rotates, that pull is actually going to vary in latitude, right? So Earth looking like this, right? If the pull is here, well, as this guy rotates, it's going to change where exactly that gravitational pull is going to be concentrated. Then the moon's orbit is not perfectly perpendicular to the Earth. It's not sitting in our ecliptic, which is why the moon doesn't block the sun every time it's in the new moon phase. It's why the moon is not a lunar eclipse every time it makes it to the full moon phase, right? Because the Earth is orbiting the sun at a slight angle to the ecliptic, right? The ecliptic being, if you were to think like a tutu coming out from the sun, and then a tutu coming out from the Earth would be the ecliptic for the moon to be sitting in. So if the moon is at a slight angle there, and then the Earth is at a slight angle to the sun, all of these factors are going to affect the position of the moon's gravitational pull. It also brings in this idea of apogee, perigee, where the distance of the moon to the Earth varies. So I'm just going to write apogee and perigee. Apogee is when the moon is farthest from the Earth, so the tidal force, right, that gravitational pull is going to be a little bit less. And then when it's closer, when the moon looks super big, we'll expect to have a higher tide. In the same realm or idea, the gravitational pull of the sun is going to vary because the sun goes through not apogee and perigee, but instead we have aphelion and perihelion. And aphelion, perihelion, peri again meaning near, that's when the Earth is closest to the sun. That actually happens, ready, January 3rd. Right? January 3rd, we are actually closer to the sun, which is counterintuitive to us because we think, oh, it's the winter time, it's so cold. But we're actually closer January 3rd. Aphelion, we're furthest from the sun on July 4th. So this year on Independence Day, be like, Happy Aphelion Day! Alright, don't really do that. Most people have no idea what you're talking about. Next, the ocean basin shape is going to affect the swell of water and the movement back and forth. And then the focusing effect of the bay, right? If we have a closed off bay, if we have a barrier that's actually slowing the water's movement in and out, we can actually get a bulge. So that's what the next few slides talk about, so let's get there. Tilt of the Earth again, can't say it enough, 23.5 degrees. And this is going to affect where the bulge of water is going to be. The moon's orbit, because it takes an extra 50 minutes to complete its orbit each day, that's where the the shifting of tides come from, because it's wherever the moon is that we're going to get that high tide, low tide. So this really sets up for the diurnal system. And then I added in, again, the apogee and perigee, because that's going to affect the gravitational pull. Gravity is affected by the mass and the distance. So that's why the moon's gravity is stronger than the sun's gravity when we're talking about high tide, low tide. Then we talked about the gravity of the sun. And this now gets into a little more detail. So I gave you the aphelion, perihelion. Now we're going to look at spring tide and neap tide. And spring tide is when the moon and the sun are in the same plane, right? They're all in the same plane. So that happens during the full moon phase, which we just saw at the beginning of the week, and the new moon phase, which we'll see in another week or so. This is when the sun and the moon are pulling on the earth and the water. You're going to get the highest high tides and therefore the lowest low tides. So we call this the greatest tidal range. Greatest tidal, sorry, the textbook calls it reach. Greatest tidal reach, right, during spring tide. By the way, great diagram. By contrast, if the moon is pulling in one direction and the sun's pulling in the other direction, we establish what we call a neap tide. I think of neap tide as neutral. A neutral tide means that when one pulls one way, one pulls the other, neither one can dominate the other. And if you look in this picture, the bulge is pretty even around the earth. So we're going to say lowest tidal reach. Again, great little diagram. I'm actually looking this afternoon for some questions where maybe there's a diagram, but rather than a label diagram, maybe I'll ask you some questions about what's going on in a particular arrangement. So it hopefully will open up an avenue for some fun questions, but things that are a little bit easier than just, okay, I know this is the moon, that's the sun. Like, let's put a little content in there. The ocean basin, right? The shape of the ocean basin is going to influence the rise and fall of water. And then we said before, the focusing effect of the bay. If there's a narrow point, right, the water can rush in there. We can actually get an especially high flood tide. Now, this is the last really cool point that I want to bring up. The moon is in essence a braking system for the earth. See, if the moon were to like disappear right now, I don't know, like Despicable Me, right? Gru goes out, boop. If they were accurate with that film, the earth would instantly start rotating faster. If the earth were to rotate faster, the days would become shorter, and the year doesn't get shorter, but instead we would have more days within the year. All right, but luckily that's not going to happen. So let's move on to the next point. The take-home message, right? Tides are generally twice daily or diurnal. They're caused by the tide-generating force. All right, so things I'm focused in on, if I were going to write some test questions, gravitational pull on the moon and sun, and then centrifugal force. And then the factors that affect the tidal reach, right? Remember, the tidal reach is the difference between high tide and low tide. All right, just about done. Right now, you're going to need to insert the next set of slides. But when you do that, you're going to have to delete the first 27 slides. So I apologize for that. It should only take you a second. So go ahead and hit pause, make that happen, and then I'll continue. All right, so hopefully you actually hit pause. Now, as the waves move landward, what is going to actually happen, right? You go down to the beach, you see all the waves breaking. We learned in the lab the other day that we have a wave base, which is the energy that's basically spiraling underneath the water that we don't actually see. And when that wave base gets compressed along the continental shelf, this is going to take the wave from a nice symmetrical, right? Height is half of the width, to now compressing it. The top part of the wave actually starts to push ahead of the wave base, and that's why you get the breaker. That's why you get that classic crest in the wave, right? That idea that the wave is actually going to like curl back this way, right? And then we got water, and here maybe you're a little surfer person. I don't know. You guys can draw much nicer than I can. All right, so let's get into it. Breakers, super important. We'll see that in a diagram in a second. The wave comes in, smashes down on the shore. So I know myself, my daughter and I like to go and jump in the waves down here. She gets kind of scared, but the swash is that breaking of the wave now and spreading out of water. Then when the water goes back, right, when it pulls back, that's usually the part she gets a little scared of. That is going to be the backwash. And that's when sediment gets pulled underneath. That's going to be really important when we talk about rip current. So breaker hits the land, that surge of water we call the swash, and then that water flowing back into the ocean is the backwash. As the waves now approach the shoreline, typically they're coming in around a 45-degree angle, but the wave base coming in contact with the seafloor slows the initial part. So when you're closer to the shoreline, you move a little bit slower. When you're further offshore, you move a little bit faster. And that's what we're seeing in this picture down here. All right, we're coming in at 45, but this area out here, moving a little bit faster, curves in. This creates what we call wave refraction. And when you're no more than 5 degrees, we actually start to generate what we call a longshore drift. So we're actually going to start pushing material down in this diagram to the right, in a sawtooth pattern. So we're going to push it. It's going to be pulled back out by the backwash, and over time, sediment just bounces down the shore. As I said before, the wave base down here, this makes, by the way, a great diagram. We know that these are our oscillating waves, right? And then over here, once the wave base comes in contact, the shape now changes, right? So we lose the symmetry. The top part starts to push forward. This is going to be your breaker over here, and this right here is going to be your translational wave. So TW. Back here later on, we're going to find out this is called a lagoon, and then over here, this is your dune. So lagoon and dune, all good anatomy to know, or profile of a shoreline. Can anybody think diagram? I don't know. Anything's possible. All right. So waves approach the shore, as we just said. They don't just come in parallel. Instead, at a slight angle, we're going to get this longshore current. Because of the longshore current, we can end up with a longshore drift. So we can get that movement of sediment to move at a slight angle. So just to review, you have wave refraction leads to longshore current, leads to longshore drift. Too easy. But there's one note real quick, right? A strong backwash, right? So that strong water pulling back into the ocean. can generate what we call a rip current. And rip currents are super dangerous. These are strong seaward flows of water. So the water is actually being pulled back into the sea. When people get caught in a rip current, they have this instinct of swimming back to the shore, but in reality, they should try and swim perpendicular or parallel to the shore, perpendicular to the way they feel they're being pulled, and eventually they'll get out of that rip current, and now they can turn and swim to the shore. Otherwise, it's kind of like swimming on a treadmill, and you can become exhausted and tired and drown, and we don't want that. So be careful of these rip currents. All right. Now, on to beaches and tidal flats. So we all know when we say beach, we're thinking an area along the shore that is going to have an array of different sediment. If we think of any of the Fire Island beaches, they tend to be very sandy. If we go to a North Shore beach, they tend to be very rocky. So I want you to be thinking sandy beach versus rocky beach as we move forward. Now again, diagrams are super important, and this particular profile diagram shows you the two different types of waves that we talked about before. We see over here the breaker. In here you have your intertidal zone, dunes, marshes, which we'll talk about probably on Monday, and then lagoon. So great little diagram, a lot of detail in there. Notice I just filtered out a lot of the extra stuff. Now, where waves roll onto the shore at an angle, grains are going to be pushed along in that sawtooth pattern. This is what we're talking about as longshore drift. So it's the parallel movement of sediment down the beach. This longshore drift can set up for the formation of a sand spit, or what I just call a spit, a barrier island. Barrier island, like Fire Island? Absolutely. Lagoons, which is going to be the shallow sea area behind a barrier island. I don't quote me on it, but think of the Great South Bay being that area behind the barrier island. It's a little deep to be a true lagoon. And then you have a tidal flat where this area is completely submerged but gets pretty shallow during low tide. So these are some good definitions. You can go ahead and hit pause to fill in your notes, and then you can continue. All right, so beach profile structure. Because of the movement of sediment in and out of an area, they use this word sediment budget. Not the first time we've used the word budget, right? We talked about budget when we did groundwater, right? We said that when we had more water coming in, we had a surplus. When we had more water coming out, we had a deficit. Here, when we have sediment being deposited, we're going to build these features like sand spits and barrier islands. When we're carrying a lot of this material away, we're going to be using the word wave erosion. So, we talked about sand. Now we're going to talk about rocks. That's going to round out today's discussion. North Shore beaches, rocky coastline. Right? The wave action in a lot of areas that have rocky coastline basically take away all that smaller sediment and cause the cliff faces actually to just break down, giving you these really rocky coastlines. So think of undercut cliffs, just like we looked at with like waterfalls, where you get that undercutting and then the rock fall effect happens, mass wasting, drops a whole bunch of material and creates these rocky coastlines. And that's what you're seeing in this picture here, right? That's that undercutting. And then over time, right, because of the wave action, it undercuts and then it drops down, making a pretty rocky beach. All right, I'm stopping here. I hope you guys have a great weekend. I'm giving you some practice questions for homework, and I will talk to you guys on Monday, one way or the other. Thanks, guys.